Hello there, we're on to our second unit, which is about graphing linear equations. The first thing we'll look at is plotting points. So a couple of things to review about graphs before we plot these points. The first one is that this is the x-axis over here, and this one here is the y-axis, meaning that this is the x line and this is the y line, right? And down in the middle, this is where we have at point 0, 0, this is where we have the origin. All right, so plotting points. Sometimes the points have names indicated by a letter, and it's just like Battleship. You have a set of instructions here. How far do I go over on the x-axis, and how far up or down do I go on the y-axis when I'm going to plot the point? So we'll look at our first one here. We've got point A is at 1, 4. So we come down to our graph, and we count over from the origin. We count over 1 and 4 up. And there's our point there. It's not a very good point, but there it is. And the second point here has us going in a negative direction for both x and y. So we count over on the x-axis, we go left by 2, negative direction, and then we're going to go down by 5, 2, 3, 4, 5. And there is my point B at -2, -5, and point A was at 1, 4. And we can actually graph a straight line given certain types of information. The first type of information we start with is x-intercept and y-intercept. Well, the x-intercept is here 1, and we know this is our x-axis, so the x-intercept is actually where does my line cross the x-axis, and there it is down at +1. Should be right on the line there. And the second piece of information, the y-intercept, well, that's talking about the y-axis, and we're crossing the y-axis at -5. So I count down to here, and there it is. And so we've got our 2 points, and you can graph any straight line as long as you have 2 points because the line never changes direction. So that's all that's required. So I'm going to do my best, and my line is not a very good match according to the points, but it's close enough for you to get the idea. And there it is. That's all I need to do to be able to graph something like that. Here we have a special case. I'll make up a different one. X is equal to +3, I guess. It looks like we don't have enough information to graph when we're only given this x is equal to something. So we're working off the example that x is equal to +3. And when I do, what that means is that it doesn't matter what y is, x is always going to be equal to 3. So if y is -3, here we are, x is over here at +3. This gives us, once we draw it, this gives us a vertical line. We look at an equation in a different form next, and that is something like this. Y equals 3/4 x minus 2. We may do this example, or I might do something slightly different, but a couple of parts we need to look at are that m is the slope and b is the y-intercept. Okay, so when y equals mx plus b, we have enough information to graph a line really quickly just with those 2 pieces of information. When we get into what the m value or slope means is how much do I rise, do I go up or down, over how much do I run, which is left or right. And so slope, when we look at it, because we're going to have a fraction, a set of instructions like 3/4, well, if the top number is positive, we're going up. If the top number is negative, we're going down. If the bottom number is positive, it means we go right, and if it's negative, we go left. So I've made up our own example that we're going to graph here. Y is equal to 1/2 x plus 2. I suggest you start with your y-intercept because that's your starting point. Okay, so y-intercept of +2 is now on the graph up there on the y-axis at 2. We now take that information, and we've got slope, which is a set of instructions, and our line is supposed to go up 1 for every 2 that we go to the right. Both those values are positive, so we go up 1, 2 to the right, and there's our second point. And that's all we need, but you could keep following those same instructions and go up 1, right 2. Alternatively, there's another way to look. A fraction is still overall positive if both the top and the bottom values are negative. I've tried to indicate that there. So -1 over -2. And look what happens. If I go back to my starting point, and if I go -1 means down 1, and -2 means left by 2, look at that. I end up still on the same line. So you can manipulate the signs in the fraction as long as the overall fraction remains the same. You know, if it started positive, it has to have an overall positive value, and if it starts negative, it has to have an overall negative value. Next, we'll look at a similar line, but it has a negative slope. And we're going to take a look at how that affects the way that we graph it. So we still start with our starting point, which is the y-intercept. So we start down here at -1, and that is a point on our graph, so we can mark it right away. Now, the slope in this one is -2/3. And the trouble here is, in this example, well, the negative sign's out in front of the fraction. So what does that mean for rise and run? Do I go up, down? Do I go left, right? Well, there's two different ways to look at well, there are more than two ways, but there are two ways we will look at this negative fraction. And if we're saying that the fraction is -2/3, that can either mean -2/3, +3, or it could mean +2 over -3. They will both give us correct directions on how to graph our line, and I'll show you how first. So in the top one here, we're going down by 2 because it's negative, and right by 3. So down 2 and right 3. There, I have a point down there, and we follow the second set of instructions where we're going up 2 and left 3. Okay, so I count up 2, left 3. What do you know? We are still on our line because the directions, because the overall fraction were both negative, it stays true to what the slope was intended to do. We've come across a special case now within this practice set. Well, what do we do when we only have this information? Y is equal to, well, I made up a new example. Y is equal to 2.5. Well, it's similar to what we did over here when we had x was equal to, the example we used was x was equal to +3, and that gave us a vertical line at +3, because no matter what y was, x was always 3. And here, y is always equal to 2.5. So what that means is, okay, well, there's y at 2.5. If x is 1, there's y at 2.5. If x is over here, y still 2.5, and so on. And what we end up with is a horizontal line at y equals 2.5. And that's what our graph should look like. And just a couple of notes here about the slope of a line like this in this special case. Well, if we think about slope is equal to rise over run. Well, this line is not rising, but it does have run, so it is moving left and right. So I got 0 over just a check mark because I don't have a value here that I want to use. That, when I divide it out, will become 0. So the slope of any horizontal line is 0. As we move over to our vertical line example, in this special case, we've got slope, and we've definitely got rise because it is going up and down, but we don't have any run. And we run into this problem in math when we try to divide by 0, and the result when trying to divide by 0 is undefined, if I can write it. So just keep in mind those two slope values. So a vertical line has an undefined slope, a horizontal line has a slope of 0. And the last example we look at is when the line is not arranged in y equals mx plus b form. That's called slope-intercept form. What we have here is something that's closer to standard or general form, and what we really need to know is, well, I guess there are several ways we could graph a line using this standard form. For example, we could get the intercepts by setting x and y to be 0. What I'm going to do in this example is I'm going to rearrange and solve for y. Once I rearrange my equation to solve for y, I will have my y equals mx plus b form, and I'll be able to easily graph. So let's do a bit of algebra and rearrange. So for y, if it was positive 2 on this side, well, I subtract 2 from both sides, and 2x goes from the left being positive over to the right being negative, and we also already have our negative 8 over there. Okay, we want to know what y itself is, but we know what 4y is. So what we need to do is divide both sides of the equation by 4. We're left with y is equal to. Okay, so on the right-hand side here, both the negative 2x and the negative 8, both of those have to be divided by 4 because the 4 is affecting both terms. So negative 2 over 4 gets me minus 1 over 2x when I reduce it, right? 2/4 reduced down is a half, and that's what belongs to the x value. And negative 8 over negative 4 should be negative 2. So there's the equation of my line. Y is equal to negative a half x minus 2. My starting point is my y-intercept. There I go. And the way I've written it here, it looks like I'm going to go down 1 for every 2 that I go to the right. And there it is. Alternatively, I could go up 1 for every 2 to the left if I was to put the negative sign in the bottom of the fraction instead. Okay, so let's just prove that that works. We would go up 1 and left 2, and we are still on our same line. I can now graph this thing really quickly, and that's about it.